Hello, welcome again to another solving simultaneous equations. So we have 4x plus 3y is equal to 17, and then in the second equation you have 5x minus 2y is equal to 4. Alright, so we're going to call this equation 1. We're going to call here equation 2. Alright, which variable do we eliminate? Let's look very closely. So I have 4x and I have 5x. If I multiply equation 1 by 5, I get 20x. And multiply equation 2 by 4, I get 20x. That's one way of solving for this. Okay, let's look at our y terms. I have 3y up here and I have minus 2y. So I take equation 1 and multiply by 2, I get 6y. And I take equation 2 and multiply by 3, I get minus 6y. Alright, so if I multiply by 2 and 3, I might actually be the easier way. I have less numbers to work with. Okay, so if I take equation 1, so if I take equation 1 and I multiply by 2, let's see what happens. So I'm getting 8x plus 6y equals to 17 times 2, which is 34. Alright, now this I'm going to call equation 3. So I'm creating a new equation. Alright, if I take equation 2 and I multiply by 3, let's see what happens. Alright, so 5x times 3 is 15x. Alright, and now I have minus 6y. This is equal to 4 times 3. 4 times 3 is actually 12. So I'm creating another equation, a new equation, which I'm going to call equation 4. Alright, now watch it again. So if I was to add equation 3 to 4, this contribution of the y's will produce 0y. So I would eliminate the y terms here. Alright, leaving me with this to work out the value of x. Alright, so if I was to take, so let me draw a line here. Alright, so if I take equation 3 and I add to equation 4, what shall I get? (8x plus 15x), that will give me 23x. Alright? 8 plus 15, 8x plus 15x is in fact 23x. Alright, we already established that 6y minus 6y is 0y. So that's 0 contribution out of those two terms. So now I have 34r12. 34r12, this will give me 46. Alright? Alright, so you have 23x equal to 46. So we're going to divide 23 on both sides. So your x is equal to 46 divided by 23. So you get x is equal to the value of 2. Alright? Now you're going to take x equal to 2 and substitute into equation 1 or equation 2. Alright, you have a choice in the matter. Alright, I would take the easier equation to work with. Which is easier to work with? I have minus 2 here, I have 5 here. Alright, and I have 4. So that's simpler numbers to work with. Alright, so substituting into equation 2 might be the smarter way out, might be the easier way out. Alright, so let's see what happens. So if I substitute x equals to 2 in equation 2. Alright, so I get that 5 open bracket 2 minus 2y equals to 4. Alright, so 5 times 2 is 10. 10 minus 2y equals to 4. Alright, now the idea is to solve for y. So if I carry across the minus 2y to the right side, you're going to have a change in sign. You're going to carry the 4 to the left side, so there's a change in sign. So you get 10 minus 4 equals to 2y. 10 minus 4 is 6. 6 is equal to 2y. Alright, divide by 2 on both sides, and I'm getting that y is equal to 6 divided by 2, so you get that y is equal to 3. Alright, so this tells me that the final solution here that satisfies equation 1 and 2 is x is equal to 2 and y is equal to 3. So x is equal to 2, y is equal to 3. Alright, this satisfies this pair of linear equations here. X equal to 2, y is equal to 3. As a way to double check, if you was to take x equal to 2 and y is equal to 3 and put it back into equation 1, the left hand side would actually give you back 17. That is 4 times 2 plus 3 times 3. Simplify that, you'll get back the value of 17. Similarly, plug it into equation 2, you'll get back to 4. That is a way to double check your answer. Okay, thank you for listening, thank you for viewing.